Hi, I'm Abhip Sakar, a master's student of Connected Environments course, and for my dissertation, I would like to present my context-enabled activity sensing system. The launch of the first generation Fitbit wearable device in 2009 catapulted activity tracking into the spotlight, culminating in a myriad of mobile applications and standalone devices, especially the ones that track health and wellness. While the present activity trackers classify the activity type accurately, the lack of context renders them meaningless when viewed afterwards. Some activity trackers like Fitbit and Strava record location when the user is outdoors, but the absence of GPS in enclosed buildings limit the activity trackers indoors. This Android app called Retrace Workplace attempts to solve this problem by identifying the room where the user is and synchronizing it with the activity output. The app is installed on a Google Pixel 4a Android version 12 smartphone. For activity data, the app uses the accelerometer and step sensor to classify user activity into three categories: stationary, moving, and walking. For the location data, the app uses 38 Bluetooth low energy beacons called Beaks installed in 5 different rooms of the CASA lab. The app contains 3 pages: Home, Tracking, and History. The primary purpose of the home page is to scan for the geofencing beacon that is installed to detect whether the user has entered the office premises or not. However, for the app to work, user needs to switch on the Bluetooth and location on his phone, as well as allow activity tracking permissions for the app. If the Bluetooth is not switched on, the app shows a snack bar message to remind the user. When these permissions are allowed and user enters the geofencing range, the tracking page is enabled and the status message is updated as shown. Once the user moves to the tracking page, the user can start the activity and location tracking by pressing on the start button. The card on the top of the page shows the current readings of the activity and location separately. The card on bottom shows a line chart visualization of a complex activity. For example, if the user is not walking and they are in the lunch room, they are assumed to be having lunch. Similarly, if the user is in lecture room, they are assumed to be working. The app shows 5 complex activities: lunch, work, meeting, transit, and socialize. Once the user exits the office premises, they can press the stop button to stop tracking. The reset button clears the line chart and resets the activity and location cards. To support long-term reflection, the data thus collected is stored in SQLite-based local database using RoomDB Android library. On the third page called Analytics, the consolidated duration of each complex activity can be seen for any particular day. Currently, this app supports only an indoor mode, but in future, it could be enhanced to add an outdoor mode that uses GPS as well. Such an app would improve the current activity trackers by automatically transitioning between the two depending on user's location. By adding BLE beacons to other indoor spaces, this app can potentially be configured to track homes, offices, and other indoor spaces to provide accurate spatial context wherever the user is. Thanks for listening. I hope you find the app useful.